Okay. I'm honored to introduce the first speaker today, Ms. Lori Garver, NASA Deputy Administrator. It's honor for us to have you here. People speak about space, and space cooperation, and space R&D and space investment. I think if you check the activities of the whole world in space, something like 80, perhaps 90% of it is NASA. So sometimes we feel as, NASA is the giant and we are very modest. Still, space is space and cooperation is cooperation. Ms. Lori Garver spent most of her life around space, including various positions in NASA. She has a BA in political science and economics and master's degree in science, technology, and public policy from George Washington University from 1989. Please.
Professor Clapper, if I could have you come up. I know you can't stay, so I'll make the presentation now. You mentioned we may be the giant. We're a friendly giant, right? And it's very interesting to be in a position as we are. There are no leaders, after all, unless we have people who want to go where we are going. And Israel has been that country for us for a very long time. Obviously, we are honoring, I'm here personally honoring the memory and life of Ilan Ramon, who really represented the best of your country. We have asked a lot of your nation, and we thank you for what you have given. We will continue the mission together. And in honor of that, we have flown an Israeli flag on the space station along with the American flag, and I would like to present this to you both for the university.
Thank you very much.
Thank you very, very much. They're going to find out. They said I could choose who to give it to, and I did not choose. It is an honor to be here, as I have been asked to talk about the NASA Space Science or Science program. He mentions it as a political science and economics major, slightly intimidating. So I'll try and take up all my time so I don't have to answer any of your questions. I'd be happy to try to answer any of your questions. It is a genuine pleasure to talk about NASA's space science missions. While you're no doubt aware of the intense debate about the future of human space flight and where we are going in the United States, I'm here to tell you, first of all, that it's a very positive debate. And I, for one, believe intensity is a good thing. When you have members of Congress from both sides of the aisle in the United States, House, Senate, as well as up the street on the other end of Pennsylvania Avenue, the President, discussing the best way to explore space, then you've won. About 20 years ago, we were discussing whether or not we should explore space. We had a vote in Congress in 1996 that we only won by one vote to keep our International Space Station developed. So this is a positive thing, and I think that it is no doubt partly in response to the international cooperation that we see such support in our nation for human spaceflight. Now, the science part of our program has been, since our beginning, robust and continues to be, and I'll focus on that for most of the talk today. Given the debate, sometimes it's easy to overlook the space science portfolio. We did put forward an increased budget last year for both Earth and space science. But today I'm going to talk about a number of the things, the missions that we have that will launch this year. And of course, you know, those were started, some of them more than a decade ago. your opening to this conference, you mentioned that your goal is to keep science and technology on the forefront for Israel, and that's really resonates with me because that is a goal of NASA in the United States. If you listen to the President of the United States a week ago in his State of the Union address, a major theme was this investment in innovation, in science and technology. I joked the next day at our senior staff meeting that if you were in my house, our drinking game was to have a toast each time he said innovation, competition, and education. You would have been feeling a little tired the next morning because this is what the speech was primarily focused on. We are all in this global economy having our own challenges. We have challenges with our deficit, but he equated the science and technology portion of the budget to the engines of an airplane, stating that while your airplane is aloft, it would be like cutting your engines if you were to cut the science and technology portion of the budget. You would be okay for a while, but you would sure feel it on the downward slope. So we feel very confident that we will continue our leadership in these areas, but of course we have to continue to help educate the taxpayers, those people who invest in NASA for us. So since the beginning of NASA in 1948, our Declaration of Purpose, one of the primary purposes and principles was that we should expand human knowledge of the Earth and of phenomenon in the atmosphere and space. That was pretty forward-leaning in 1958 by President Eisenhower at the time, but this foundational document continues to drive our efforts. While we were born of the Cold War and the post-Sputnik era, the U.S. space policy continues to reinforce that we explore for all humankind. The National Space Policy that we just completed last year provides civil space guidelines that specifically address NASA's mission in a coordinated international way and focuses on science and robotics. Specifically, the mission from the space policy includes to send more robots into the solar system to help us learn about, scout, and for new destinations and test new technologies. To continue our strong program of space science for observations, research, and analysis of our cosmos, and in concert with other agencies, increase our Earth-observing capabilities and knowledge of weather and natural and anthropogenic phenomenon of our planet and the gathering of data about it. This is the policy of the United States. We believe that we have had a consistent policy since the beginning of NASA in 1958. So the findings of the NASA science community continue to rewrite the textbooks every day. Across disciplines and geographic regions worldwide, we aim to achieve a deeper scientific understanding of the Earth, other planets, the solar system bodies, our star system in its entirety, and the universe beyond. So while we meet today's needs to invest in that science and technology research, we also aim to inspire and to continue to lead ever-expanding missions outwards. So this is really a depiction of some of our Earth science programs that, again, when we have been asked by the President, challenged to think beyond the next mission and beyond the next political cycle, we really think about what we want to be and where your generation of folks can take us. I was meeting with your Minister for Science and Technology, Professor Hershowitz, Minister Hershowitz, and it's very interesting to me that you have the exact same challenges as we do to try and look beyond just the current election cycle to enjoy the investment that we know will ultimately pay off for us. So we need missions that not only look back at Earth, but look out and inspire that next generation like you, because we really believe that our youth, as you go to pursue careers in science, technology, engineering, and math, or STEM as we call it, are critical to our future as a nation, but really as humankind as well. We want to not only head for Mars, but to have a full suite of knowledge by the time we get there about our potential water sources, where to go so that we can make the best use of it when we get there. We want to develop capabilities to visit all the interesting places in the solar system, and when we get there, to be able to stay. Driving all of our activities is that question of why. Why do we explore? And at NASA, we've recently undergone an activity to talk within the senior management about that. And what we've really come up with is that we do reach for new heights and reveal the unknown. It's one of those NASA does things that others cannot. And why we do this is to benefit humankind, so that the things we do and learn are really for the benefit of all. And this has been a wonderful discussion to have, because as NASA has a quite robust, more than $18.5 billion budget carrying this out for humankind, it helps us focus when we need to make determinations about what we should be doing. Well, we should be doing the next really difficult thing, the thing that others cannot do. So in addition to humanity's drive to explore, there are also practical results of exploration that benefit life on Earth, things like insulation for fire suits that were originally developed for spacesuits, or water processing technology developed for the International Space Station that can help people without access to clean water. So the space station is someplace that we have been living and working for more than 10 years continuously, and we've just given it more, at least, than 10 years of life. We've extended it until 2020 with our international partners. This means that our research aboard it is really beginning to pay off. We've already learned about how we can test for vaccines. We've got a vaccine for salmonella that's already in FDA trials. We're working with our own National Institutes of Health, so those of you interested in the life sciences, this can be your laboratory. I'm sure we will hear more about it from TJ Kramer. There he is in a moment. This is him exercising in space, and I'm sure he'll tell us more about the incredible research we're doing on the space station. Physical sciences and technology development experiments will investigate how gravity affects combustion processes in space, how fluids and liquids behave. This is the kind of thing that while we are reaching out, the space station is our toehold to the universe, it is also providing benefits every day for your physique, obviously, while you stay in space. And then there's the ineffable and visceral reason we explore, to raise the human spirit, to inspire awe, and to connect with each other as part of the human race, as stewards of our planet. So this part of the world, at this particular time, really resonates, I think, with that message. At NASA, our science programs are not only at the core of our mission, they're really at the core of the human experience. We love to ask the big questions and help find answers. So long before people could even fly in airplanes, there was space science. People have been observing the heavens for centuries and changing our conceptions of the universe from the first time we looked up with a serious intent to learn something. So this year is getting very busy at NASA. On February 14th, for your Valentine's Day pleasure, we have another encounter with Comet Tempel 1 with our Stardust spacecraft. So this encounter will teach us more about how this comet and others like it were formed, which is about 4.6 billion years ago. We'll be getting hard evidence from these fossil keepers of the solar system. And we're going to get evidence how our solar system formed and evolved. On February 23rd, just a week later, we're going to launch the Glory mission from California to gain a better understanding of Earth's climate system. It's specifically looking at aerosols. And then just one day later, on February 24th, we'll launch the Space Shuttle. The next mission is going to carry R2. This is our robot, Robonaut, as we call her, and she will teach us about robot-human interaction. It's to me with her before she was packed away. And then in March, Messenger becomes our first satellite to orbit Mercury. Now, just later in the year, we're headed to Mars. The Mars Science Laboratory, also known as the Curiosity rover, scheduled to land on the red planet's surface on August of 2012. It's twice as large and 3 times as heavy as our previous rovers and about the size of a small car. It's going to help us learn about whether life ever did exist on Mars or maybe is still possible. Then the Dawn mission. It reaches the asteroid Vesta in July, out there in the main asteroid belt on its way to the dwarf planet Ceres, and New Horizons will finally reach Pluto in 2015. So science and exploration programs are working together with our human programs to be robotic explorers, scouting destinations and sending back data before we can go as a species. At the same time, they do vastly increase our scientific knowledge and test our technologies. One of those programs, the Lunar Reconnaissance Orbiter, is a great example of this two-pronged approach. Its initial mission was for exploration, mapping the surface of the moon and providing data to help identify sites, interesting sites for future landings. And it is also now a science mission. It's created a map of the moon in unprecedented detail, discovered that its shadowed craters are some of the coldest places in the solar system, and has supported the L-Cross mission's analysis of the debris stirred up by its impact in one of those craters. Now, I want to just highlight that Israel is one of our partners on NASA's Lunar Science Institute, and there is so much more left to be learned about our nearest neighbor, the moon. So we look forward to working with you in any capacity along those lines. She will undoubtedly have continued to reveal her secrets. So science does have a bright future at NASA. We can definitely predict that with no reservations. It's one of the most international areas we work in as well. We have over 500 international agreements across NASA to carry out our cooperative research. We fly instruments on other countries' spacecraft, their instruments on our spacecraft, and carry out programs like SERVIR, which combines Earth and space-based observations data to help assist local, primarily developing nations with resource utilization and disaster response management. Another international program where you play a major role is the GLOBE program, Global Learning and Observations to Benefit the Environment. You have over 50 schools, you have 51 schools, I believe, in Israel so far, who work with us on the GLOBE program. Students taking science data, working with students across around the world in order to then help analyze data in new ways. So NASA is known for our astronauts, for sure, but we're also known for our science. Mars rovers, Spirit and Opportunity. I know there'll be a lot of concern when these rovers finally take their last steps. They're not stepping, they're roving. But we share this experience of science with the public in as many ways as we can. Hopefully you sign up for Facebook and Twitter from Spirit and Opportunity. We have Hubble data coming back 24 hours a day. Our spacecraft Fermi and Chandra are all part of this great public dialogue with space. Robonaut, of course, will be tweeting. I think Robonaut already has more Twitter followers than I do, which has not made me very happy, but I understand she's very popular. So more NASA scientists are necessary for your future. I would say space scientists generally. We can't all be astronauts, but as I mentioned, the space station is a laboratory we can all learn from and conduct science in space. I don't know if you heard about the 9-year-old about 2 weeks ago who just discovered a supernova. I did tell my children who are teenagers that they are far, far behind. Slackers, all of them. If a 9-year-old can take the data that we get from our spacecraft and discover a supernova. So, while NASA has dozens of missions in space, which are constantly sending back amazing discoveries, This is really another golden age of exploration. I just wanted to give you an overview of what's coming up in the next year or so. With your help, we can have even more discoveries, and it is an honor to be here with you. I have really gotten to spend a little bit of time with some of you, and I look forward to continuing partnerships as we go forward in space together. Thank you very much. Shalom.